In this example, a discrete time signal is given and we are asked to find the Fourier series coefficients of this signal. To solve this problem, we use some properties and also some well-known practical examples whose results we should always remember. First, we introduce a signal called the impulse train. In this signal, all amplitudes are equal to 1. If we denote it by Pn, its Fourier series coefficients are equal to 1 over n. So we can say AK equals 1 over n. Now, if for example we have 2Pn, then its coefficients will be AK equals 2 over n. This is a very common signal that we use frequently. Now we also use the time shift property. This property says if xn has Fourier coefficients AK, then xn minus n0 corresponds to e to the power of minus j k omega 0 n0 times AK. Now we want to express xn in terms of Pn. If you look carefully, the signal is periodic with period 4, so n equal 4, and omega 0 equal 2p divided by 4, which is p over 2. Now we rewrite the signal. In this signal, we have 3 impulse trains. Pn with n equal 4, a shifted impulse train starting at n equal 2, so we write 2p n minus 2 and another shifted term minus p n plus 1. Now we compute the Fourier coefficients. For the basic impulse train, the coefficients is 1 over 4. For the shifted term 2Pn minus 2, we have n0 equals 2. So this gives 2 e to the power of minus j p times 1 over 4. For the term minus p and plus 1, we have n0 equals minus 1. So this gives minus e to the power of j p over 2 times 1 over 4. Now combining everything, we get AK equals 1 over 4 times 1 plus 2e to the power of minus j cap p minus e to the power of j cap p over 2. Now let's compute some examples. For k equals 0, A0 equals 1 over 4 times 1 plus 2 minus 1 equals 1 over 2. Now for k equals minus 1, we substitute and get a minus 1 equals 1 over 4 times 1 plus 2e to the power of jp minus e to the power of minus j p over 2. Using Euler formula, e to the power of jp equals minus 1 and e to the power of minus j p over 2 equals minus j. So the results becomes a minus 1 equals 1 over 4 times minus 1 plus j. In this way, you can solve similar problems. In this video, we solve the discrete time signal problem using a practical example and an important property to find the Fourier series coefficients. If you are interested in more problems like this, you can follow this channel.